Hello and welcome to this presentation. My name is Vishal, and this tool that I'm about to present today is called Vovk. It is a ERR rule generator, and we call it the Advanced Dynamic ERR rule generator. Why exactly is that? We'll see in the coming slides. Quick introduction. My name is Vishal Thakur. I work for a company called Huntress. I manage the Australian Threat Ops team. I also am the founder of the HackSeed conference in Sydney and also the B-Sides Sydney Security Conference in Sydney. Here you can see a QR code that literally just takes you to my LinkedIn profile. So please feel free to join me, link me up on LinkedIn, and let's keep the discussion going over there. A very quick presentation intro. We will be covering a few things today in this presentation. These are some of the things that will be covered in the next half an hour or so. We'll quickly look at what is Vovk, what actually is the tool, and what it does. We'll very briefly touch upon the debugging extensions, what they are, and what the purpose of them and how they're built, a little bit about that. What are YARA rules? So we'll definitely have a look at YARA rules, and I just briefly jump into that as well. What are the components of Vovk? So we'll quickly have a look at what actually comprises of this framework that we call Vovk, and we'll have a little bit of a discussion about that. How does Vovk work? That is the main chunk of this presentation. So that basically will be me explaining how all the components come together and how it actually achieves the goal that we set out for, followed by an actual live action demo of the tool in action. Basically, we'll run a demo, we'll see how it works, and we'll be able to share that info as well. Why advanced? We'll touch upon that a little bit. Why are we calling it the advanced YARA rule generator? Basically, it does a little bit more than your, generic static YARA rule writing. So I will quickly look into that. Why Vovk? That is more around why the name. So if you follow me on GitHub, if you've seen my previous Black Hat presentation, stuff like that, most of my tools I literally just name after rules, and I tend to pick different languages for the same word. So if you are aware of my previous, one of my previous tools called Lupo, that literally means wolf in Italian. Vovk also means wolf in Italian, and this time I've chosen Ukrainian language for reasons that may or may not be that obvious. All right, let's jump into it. Vovk is a tool that will be completely open source. By the time you're watching this, it will most probably have been released. The plan is to release it as I presented at Black Hat USA 2023. How can I get it? It will be available on GitHub. All the links and everything will be shared. When can I get it? Like I said, we will release this tool at the Black Hat USA 2023, which is this year, coming up pretty soon. By the time you're watching this, it would be already happening. Will there be a wiki? Yes, there will be a wiki. There will be a full how to use the tool and all that stuff available on GitHub itself. Can I fork it? Yes, you can. Please fork it. This is a tool. It has been meant. It is literally just meant to be shared. It will be completely open source, as I already said. And yeah, just use it. Let us know if there's any issues. And by us, I really mean just me. So it's just a single person thing. So please be patient. I do it in my own time. And the last question of what there is, can I contribute 100%? Please, if you see something that I've done doesn't make sense or can be done a bit better, which I'm pretty sure is the case, please contribute to the project. Obviously, you will be recognized as a contributor, and recognition definitely will be given. So yeah, I hope that answered all those questions. What is Vovk? So let's talk a little bit more about that. Vovk is a Yara rule generator. So basically what it does is it takes a malware and it does some things which we'll have a look at in this presentation. And by the time it's done, it will give you literally a Yara file that you can use then to run against your memory dumps, your malware, and all that stuff. Vovk is a Windows based tool. It is works on Windows-based malware because it uses the Windows native debugger to extract that information that goes ultimately into the actual tool. It has to be used within debug, like I just said. In the one part of the actual tool is an extension to the debugging debugger. All right, which brings us to this next question, which is what are debugger extensions? So if you're wondering what they are, think of them as plugins. So basically you've got the debugger, which is the main application, and then you can have all these plugins / extensions that you can add to the main program, and then you can run them within the main program, which happens to be the debugger. They're DLLs. So where basically you write the code and you compile them. You do all of that stuff as DLLs. Most extensions are written in C++. Pretty much every extension that I've come across ever has been written in C++. I believe they can be written in C, but it'll be pretty complicated and complex. They are built, created to achieve specific tasks. So basically debugger is the entire engine. And if you want to do some specific tasks or you want to automate parts of your debugging process, you can write an extension for that. And all of these extensions that I've written, that I play around with, test, are compiled and built in Visual Studio. So basically a Visual Studio copy on your one of your test dev machines is all you really need to get started in developing your own extensions. Community version, the free version of Visual Studio is perfectly okay. Which brings us to the next question, which is what are Yara rules? So Yara rules are detection patterns that you can write for specific malware, specific files, and basically you're targeting attacks and security threats that you see in your line of work, and you can then use these patterns to identify these malicious files as accurately as possible. As anyone who does plays around with malware, does a bit of malware analysis would know, most of the current malware, or like we call it modern day malware, is packed, and most of them are packed using custom packers. What that really means is a lot of that malware, actually, you only get to see the full malware in execution once it's literally getting executed. Why that's really important is if you want to write Yara rules that are highly accurate, depending on the environments that you work, and if highly critical environments are something that you're working in, and the room for or the appetite for false positive is really low, then you really want to write Yara rules after the malware has unpacked. Basically, based on the information you grab from the unpacked version of the malware, because that will be very accurate and more specific to that particular malware that you're after. Well, works on packed malware. That's the entire point of this tool. And that's also the reason why we're calling it the advanced Yara rule generator. So basically, it dynamically executes the malware, and while the malware is executing in memory, and it starts grabbing information at that point, and the rule that you get in the end is based upon all of that stuff. What are the components of Vovk? So pretty straightforward. It has two components. One is the extension, which is the DLL, as you can see here. And the other one is the actual executable that gives you the Yara rule so from all the information that has been extracted. The executables I have provided both different versions, 32-bit and 64-bit. Obviously, you can use whatever works for you. But yeah, these are the two tools that you need, and they both need to be installed properly for the tool, the entire framework to actually work properly. Very quickly, we'll touch on this memory thing that we've kind of touched upon a bit earlier. Some key points about memory. So malware unpacks in memory while its execution is taking place. It starts unpacking. We can extract data while the execution is taking place. So basically, once it's unpacked and it's in full flight, we should always use this unpacked info, basically strings from the unpacked version of the file of the malware, to write the other rules if you want to write really specific, very accurate rules. So as you can see in that screenshot, that's basically us running Vovk extension. And as you can see, it starts to write a memory dump. And this dump is what we will then go ahead and write the extension, the Yara rule based upon this exact info that you see. Breakpoints are really, really important, as any malware analyst would know. When you're working in a high speed environment, you don't have time. You really need dynamic analysis most of the time, so you can get to results. You can get the results really, really fast. Breakpoints, basically, what is a breakpoint? Breakpoint is literally, think of a breakpoint as the pause button. So basically, when you're executing a process using breakpoints, you can pause that process at different times based upon wherever you put that breakpoint in the first place. There's a couple of different types. There's software breakpoints, there are hardware breakpoints. We don't need to go into that detail just for the purpose of this demo, but yeah, well, basically you can use breakpoints to analyze malware, to pause it at certain points and then analyze those points, and then you can also use it to automate your malware analysis process, as you can see in one of the tools that are released last year, Lupo, which is an IOC extractor. So basically extracts the IOCs from your malicious binaries. SXC is an internal WinDebug command, which really is first chance handling. And what that really means is the moment you see that the debugger sees that, it breaks. And at that point in time, we can then use that to our advantage, which is literally the next line on the slide, which is SXE LD. What that really does is think of it as a breakpoint at every new module being loaded. So for example, kernel 32 is loaded. We can use this command to break execution at that point. Kernel base is loaded. We can again use this command to pause at that exact point where the module is being loaded. How this all comes into effect, we'll see in the demo. Let's have a quick look at how does Vovk actually work. So as you have already seen, there are two parts to the actual framework. The first one is the DLL, which is the extension for the WinDebugger, the debugger engine. The extension extracts the strings while the actual malicious binary is being executed. also known as unpacked. Um, the extracted strings are then written to an external file on the disk. Think of it as something of a sort of a temporary file that we use to store all this data that we're extracting from the malware. Then we run the actual executable, the Vovk binary, that takes this dump that's been written to the disk as an input, works upon it and spits out a new file, which is a .yar file, which is literally a Yara rule set at that point in time. This Yara file then can be used with your Yara engine as a malware signature to detect malware. You can run it against actual binaries. You can run it against, more importantly, against memory dumps that you've already taken from infected systems. And with that, let's jump into the tool demo. So as you can see here, just give me 1 second, make sure you can see my screen. Okay, cool. So you can see my test machine here. I'll quickly show you how this whole thing works. So basically, the first step you do is you take the actual DLL that we had a look at, and you provide that DLL to your debugger. So basically, copy it and paste it in this directory, which will be shared obviously on the wiki. So basically you go into the actual debugger directory and there's a folder in there called WinExt, which is Windows extensions. So basically chuck it in there. So as you can see here, I have put it in here. So for the purpose of this exercise, we're writing the actual output into the C drive. As you can see, there's nothing here for now. Now, moving up here, what you can see is I've already attached a malicious process that is being uh, that is being executed at the moment. And just give me 1 sec. I just want to make sure that we are recording it. Okay, yeah, cool. Yeah, so as you can see, it has been executed, and I've attached a running malicious process to the debugger. What that does is gives us pretty much an how do you call it, unpacked version of that particular month. Okay, give me 1 sec. Yep, we're back. So cool. So it's all here. I'm gonna quickly have a look at what I'm going to quickly load the extension that we wrote. So basically use the load command and just the extension name. And at this point in time, as you can see, the command was successful. It has been loaded, but just to make sure, we'll run the chain command and see if the actual extension was loaded. And as you can see here, the first extension here is Vovk, which is our extension. So it's definitely been loaded. And what you can do is click on that, and it will give you the actual commands that you can run. For this purpose, there's only one, because that's all we need. So literally copy paste that particular command. You can also obviously type it in. It's not that long. And at this point in time, we'll just write. Just click on it, hit enter, and as you can see, the dump has started. And going back to C drive, you can see the actual dump file has been written. At this point in time, we can pause. We'll quickly go back here, and you can see the dump file has been written. We'll have a quick look. We'll just open it with Notepad. And there you go. You can see it's already been written. Now, at this point in time, what we can do is grab the executable, run that, and then see how that goes. basically it'll give you the YARA file of specifically for this malicious process that is being run at the moment and debugged. So we'll quickly grab the other file. Give me 1 second. Cool. So as you can see, this is the executable. I've renamed it to Vovk BH for Black Hat, but yeah, you can just use the actual Vovk. And I've grabbed that dump file that we looked at from the C drive, and I put it in this here. So now, again, quickly have a look at this. So we'll just open this. This is the same dump file that we saw earlier, as you can see here. I'm going to close it now. And this point in time, you can literally just run the tool. It will quickly run. And here, as you can see, this new file just appeared. Let's have a quick look at it. And this should be the actual YARA rule for that malicious binary that we were dynamically analyzing, executing at the time. And let's have a look. And there you go. As you can see, an entire YARA rule has now been written. And let's go and have a look if it works or not. I will switch my screens and I will give me 1 second. Cool. So as you can see, we have moved to a different machine now. It's the Remnix VM. And basically, I've got a couple of different versions of the same malware here. I've got the unpacked version that we were looking at. And I have also got the packed version that literally, get the first stage malware as before it's actually unpacked. So let's quickly run this YARA file, which is a static. It's something that was written on the first packed sample, which is a really straightforward string-based rule. Let's have a quick look and see what it grabs. It should basically grab both versions, the packed and the unpacked. Let's see if it's actually doing that. And as you can see, it picked two different versions, the packed ones and the unpacked one. The unpacked one is the dump that we grabbed from the memory. And now let's run the YARA file that was created in the last step after we ran our executable and see what it does. So basically, it should pick just the unpacked version because it's got to be really, really accurate. The whole idea being the packed version could be literally a lot of different types of files, different malware using same basic strings. But once we get to the unpacked version, it will be very specific to that one particular file that we were looking at, and it should only really pick that specific malware family when we're working on it. So let's have a look. It should not pick the packed one. It should only pick the unpacked one if it's the right YARA rule. And there you go. So as you can see, it did not pick the packed version. It picked only the unpacked version. And I will quickly show you the rules as well. Let me just quickly show you. I'll just do a real quick VI on the static one. As you can see, it had a few different strings, and those strings were grabbed from the actual binary in its packed state, and it picked that. And obviously, we know the YARA rule that the tool wrote, which was much more sort of advanced, and well, we had a look at it. And it was based on the unpacked version, because at the time we picked it up from the memory, the whole thing had been packed, unpacked. Cool, and that brings us to the end of the demo, the end of the tool intro, and Well, thank you very much. Please play around with the tool. Use it for creating your ERR signatures. They will be very specific. They will be very advanced. They will be very accurate to the actual samples you're working on. There will be a lot less false positives. And there's a couple of QR codes on the screen. Feel free to take screenshots of them or just pictures of them. The first one is just my LinkedIn profile. So, like I said earlier, when I started, do join me, and love to have like-minded people in my network. And the second one is the actual GitHub link to the tool. So, like I said, hopefully by the time you're watching this, the tool's already been released. All the code, it's all open source, like I said, and the binary is compiled and all of that stuff as well. So thanks. Thanks a lot for watching this, and I hope you like the tool, and I hope you use it in your day-to-day jobs. And please feel free to let me know if there's anything that you want to talk about regarding the tool. If you want to contribute, like I said earlier, that would be really, really cool as well. So yeah, more than welcome. Yeah, thank you very much, and until next time. Thanks. Bye.